This video is to explore the domains for the 6 trig functions, and I'm going to use the unit circle to help think about what the domains will be. And so I've drawn a unit circle, some random coordinates x, y on the unit circle, just kind of randomly put it in the third quadrant, doesn't really matter. You know, in this case, x happens to be negative, y happens to be negative, but in general, you kind of don't know, depends on where you are. And so the sine of theta is the y-coordinate, the cosine of theta is the x-coordinate, the cosecant of theta is 1 over that y-coordinate, or another way to think of that is 1 over sine of theta. The secant theta is 1 over x, which is the same as 1 over cosine theta. The tangent of theta is y over x, so it's sine theta over cosine theta, and then another video saw that the tangent of theta can be thought of as the slope of a line. That connects the ordered pair xy to the ordered pair 0, 0 at the center of the circle. And finally, cotangent theta is x over y, which is cosine over sine, and sometimes you see it as 1 over tangent theta. So kind of the reciprocal of the slope. So what I'm going to look at is what possibly can theta be in order for these functions to work out and be okay to evaluate, possible to evaluate. And we're not talking about able to evaluate it without a calculator. It's just in theory, the definition of this particular trig function would make sense based on the theta. And so the first thing is for both sine and cosine, the domain is all real numbers, because theta is an angle that could be 0, and that's where we start, could be any positive number, a small positive number, a bigger positive number, but I could go around this circle as many times as I want, round and around and around, and get as big as I want, as small as I want, super small fraction, anything in between. It's just how far did I rotate. But I can kind of rotate forever. And similarly, I could go backwards as little or as much as I wanted, so it can really be any negative number as well. So the domain for both sine and cosine is just an angle that lands on a spot, all real numbers. But now I want to look especially at cosecant and cotangent. So I'm going to go to the next page and explore just cosecant and cotangent, their domains. So remember, cosecant of theta is 1 over y, and cotangent of theta is x over y, and their domains are going to be the same thing. Because as I look at this unit circle and think about, well, what angles could I possibly have? The only thing I can't have is anything that makes y equal to 0. Really, I can't have y equal to 0, because then I have a 0 in the denominator of a fraction, and that's not allowed. I can have y be a big number, I can have y be a small number, I can have it be negative. All of these things, I just can't have it be 0. And so all I have to do is make sure theta is not some kind of an angle that makes the y-coordinate equal to 0. So when I look at where the y-coordinate on the unit circle is 0, it's only here and here. That's it. Cannot be 0 anywhere else on the unit circle. And so what angles do that? Well, certainly 0 does that. Positive pi, positive 2 pi, positive 3 pi, positive 4 pi, positive 5 pi. Okay, I'm getting bored there. It's really any multiple, integer multiple of pi, because I could go backwards too. I could go negative 1 pi, negative 2 pi, negative 3 pi. So basically, the angle cannot be any integer multiple of pi. Anything else is fine, but it cannot be an integer multiple of pi. So that's the domain for either one of these functions. So now let's go back and look at the other two. So tangent and secant. So tangent theta is going to be the y over the x, and secant theta is going to be 1 over x. And once again, their domains are going to be the same. And once again, the thing I have to look at is what makes the denominator 0? X. It's what, it's in the denominators of these, so it's that x cannot be 0. Just like before, y couldn't be 0. Now x can't be 0. So now I'm thinking, well, where on the unit circle is x equal to 0? And it's there or there. And so when I think about what's that, what ways can I land either on the top here or on the bottom here so that the x coordinate would be 0? These are the places I have to say, hey, theta can't get me there, makes an undefined fraction. And so the easiest way to get here is by making theta pi over 2, make theta pi halves. But every other way to get either here or on the bottom is I can get there by first going pi over 2 and then adding half of a rotation, either going forward 1 pi or forward 2 pi or forward 3 pi, or maybe starting here, go backwards 6 pi. Let's see, 1, 2, 3, 4, 5, 6. Really any integer multiple of a half of a rotation, any integer multiple of a half of a rotation will get me to another, starting here, it will get me to either here, because it was an even multiple of a half a rotation, so a full rotation, or get me here, because it was an odd multiple of half a rotation. And so that's the domain. Oops, forgot to put k any integer. K any integer. And so that's the domain for both tangent theta and secant theta.